Okay, I see that it's recording, so now it should be recording. So this meeting will be recorded. We'll give a quick overview of last week's part 1 of the Smart CNC rule, and then we'll continue on to the topics that we didn't cover. The Smart Rule screen, construction parameter dependency, repetitive placements for locked-out construction, Smart CNC rule siblings, universal override for drawer guides and pulls, hinge plate setup tied to Smart CNC rules, Smart Rule options, design to CNC direct. So that looks like a lot. Hopefully through all of it. If we don't, then we'll just continue on. But other than that, I think we're ready to go. Frank, are you ready?
Yeah.
Okay.
Okay, first, let's just go ahead and recap what we talked about last time. And that was basically the CNC machine library. Originally, this is where all of our CNC machining was set up. And what we've done is we've made it so that the program will create what the definitions that you see in front of you. We have 23 of them right now, but these definitions are created by the hundreds during a job. And that's what the Smart CNC rules do. They create what you don't have to create. So you make a rule basic for one set of conditions. And then if those conditions are met, which we'll look at in a moment, a machine operation occurs. So what are universals? Universals are, we talked about that also last time. And the universals basically are those CNC definitions down here that are used to make a smart rule. So without further ado, let's go to the smart rule screen. If we go to the smart rule screen, we see a number of items here. Excuse me. And what I've noticed is that if you have a particular rule set up, like I have right here, this is for adjustable shelves. And we also have some offsets, letting the program know where we should put these holes. If you were to add a new rule, many times these are not zeroed out. And sometimes the rule that you add is going to be offset someplace crazy. And you're going to wonder, how the heck did it get over there? Like a bottom, for example. It may not be at the bottom, it might be 2 inches above the bottom. Well, that's because these might not have been zeroed out. So that brings me to a really, really good point, and that is this, that when you are testing a rule, test just that rule. Watch what happens if I test all the rules here. I'm doing adjustable shelf holes, and I'm going to select some cabinet. Let's say this, how about this wall? This base cabinet, 26-inch base cabinet. Now, when I look at all the rules here, we see drawer guides over here. I don't know if you can, hopefully you can see that. These are drawer guide holes. Here are some hinge plate holes. Here's a dado for, looks like a fixed shelf. And here's a blind dado for a bottom. Well, for right now, I'm going to change that fixed shelf into adjustable shelves, an adjustable shelf instead. Because notice that while I've got highlighted an adjustable shelf, holes for adjustable shelf, it's hard to tell if we're successful in that particular smart rule because we have everything else showing. So if I took off test all rules and just tested one, now I'm going to be able to find out what that, if this one rule is being adhered to. And when we look at it, we'll probably see nothing because there are no adjustable shelves. So now we have a blank screen. That doesn't mean there's no machine on that part. All it means is that there's no adjustable shelves on there because it is testing just the one single rule. it is extremely important that in order to avoid confusion, because I guarantee you that it'll be confusing if you're creating rules and you test all the rules and hope that you're looking at the right one when you see all the different machining. So what I want you to take away from this little segment is when you are creating rules and you have one rule highlighted, right, like right here, and what we're telling the program is we're saying that we want these holes defined in what we call adjustable shelf holes, these holes down here. We want those holes drilled on unfinished ends whenever adjustable shelves occur, and according to the specifications shown at the right. Now, I'm going to change that fixed shelf into an adjustable shelf. So I'm going to go to that cabinet, bring it into the cabinet editor, go to the shelves category, which is over on the left-hand side. This, for those of you who might be new to the program, this is the cabinet editor. All these categories on the left-hand side define different aspects of this one cabinet, and this is how we customize that particular cabinet. For example, if I highlight shelves, divider, and closet rods, I can take this fixed shelf out, and how do I do that? Just click it, and now it's an adjustable shelf. Click it again, pull out. Click it again, fixed. Click it one last time, it's now adjustable again. And I'm going to put 2 in there. And we have 2 adjustable shelves. So if I hit the apply button and right click this picture, I can go into what's called a parameter editor. Now, if I click on view machining, this button does exactly the same thing as one of the buttons I'm going to show you momentarily in the Smart CNC Rules. So if I click view machining, we're going to see all of the machining on that particular part. And here we go. Here's our adjustable shelves. We have 5 holes here, space, 5 holes there. And we have in the front, we have 2 hinge plate holes. And over on the top, we have the drawer guides. And we have a bottom. Now, what happens if we put a top in here? I have no idea, but let's find out. Most people use stretchers for this. And if we decide to put a top in here, and now Cabinet Pro can also put both tops and stretchers on. We've got at least one customer who actually uses that in frameless cabinetry because he wants the extra thickness for his to stop his doors and to have proper spacing between his doors and his countertop. At any rate, if I were to view machining now, yep, well, we don't have anything over there. Maybe I should click on the part. Now let's try it. Now notice what happened just now is I clicked view machining with no part highlighted. If you click machine with no part highlighted, you're not going to get anything. So what I did this time is I corrected that little boo-boo and highlighted this right end, and now let's view the machining. Now we have the top, it looks like also blind dado, and the bottom, blind dado, and the rest of the machine that we just looked at a little while ago. Well, I'm going to take that top off because we generally don't put tops in base cabinets. Most people don't. That doesn't mean that you can, of course. Obviously, the program allows that. So if we go to shelves and dividers, I'm going to take the top off, leave the stretchers on. Now, where do those stretchers go on? Right here, nailers, stretchers, molding, and light valance. We said top horizontal stretchers. Now, on those stretchers, you have 3 different possibilities. You can have them going from left to right, which is by far the most common. But then we also have people who make stretchers going from front to back. And we have, I know at least one individual, one company does both, left to right and front to back, has kind of like a little face frame up there. But we're going to put left to back here. And by the way, when you choose all four of them, which is rarely done, but if you did do that, these would not be miter joints, they'd be butt joints. So now that we have adjustable shelves in there, I'm going to exit out of here, go back into the CNC library, the Smart CNC Rules, and we're going to check that again. Now, I told you that when you click the button that says View All Parts on all machining on this part, back in the cabinet editor, it's doing exactly what this does right here. Include all machining for this part. Those are exactly those two are exactly the same routine. And that same routine exists in the Premium Optimizer, because when you're looking at an optimized sheet, you could do the same thing. You could pick out one of those parts and find out what the machining looks like on those parts. So I'm going to just test just the rule by itself, and the rule is for adjustable shelf holes on the left end. So if I click on that same cabinet again, now we have adjustable shelf holes, and we know, because I chose to view just that one rule, we know that these are the holes that are being drilled from this one definition, this one rule. Now, if we tested all of them, then we could see all of them all over again. But the point is that when you're testing rules and you're creating new rules, make sure that you select test only the displayed rule. Now, if we were to hit the summary button here, we could look at some other types of rules. For example, hinge plate holes. This is saying that this universal that we named hinge plate holes, we want drilled on unfinished ends whenever a door is hinged to a left unfinished end. Now you'll notice on all of these rules we now have, that we talked about in brief last time, a depth override. So you can put, if you put 0 here, it's going to take the depth that is defined at the CNC machine library itself. But if you put any number here other than 0, and that includes a negative number, because remember, a positive number will tell the program how far deep down to drill, and a negative number will tell it how much you want left. So if I put a 1/4 inch in here, it would drill down a 1/4 inch from the top of that material. If I put negative 1/4 inch, it'll drill down enough so that a 1/4 inch is left. And that's really, really highly useful. Now, before I go into these construction parameters, let's stop for questions. Are there any questions? Okay, let's proceed. Construction parameter dependency. I don't know if anyone uses this, but it's kind of a cool rule. The reason it came about was because of nailers. Some people are using nailers for the front. Some people don't use, no, not nailers, excuse me, stretchers. Or nailers, actually, nailers is the same kind of concept, because you can tell the program that you have a nailer that's going on the bottom of a cabinet, but other times you may only have one nailer. Wait, let me back up. Let me say this again. Let's talk about stretchers. It's easier. It's an easier concept to think about. With stretchers, you can have usually either no stretchers and a top instead. We're talking about base cabinets, or you can have a stretcher in the front only, or you can have a stretcher in the front and the back. Rarely do you ever have a stretcher in the back only. So let's say you have a stretcher in the front. Well, the way the program is right now is that if you have two different definitions, one for the front stretcher, one for the rear stretcher. What am I talking about as far as one? Let's see if we even have one here. Hold on. Horizontal dividers. No, we don't have one. Let's make one real quick. Let's say, for example, do we have any dados? I'm going to make a new part, a new rule rather, and we're going to call this new rule. Here's a full dado, bottom dado. You know what? It may not be a bad idea just to make a stretcher by itself, stretcher definition. Let's go back into the library, the CNC machine library, and what we're doing right now is concentrating on the stretchers because I want to explain to you what that construction parameter dependency is all about. So I'm going to make a new definition, and all these pictures around here drive me crazy. Just one second. Okay, a new definition, and this definition is going to be a, we'll use a 3/8 compression tool. Machine operation is going to be just a regular dado cut, because this is going to be for a stretcher. And we're going to call this whatever, stretcher front, for lack of a better word. And depth of cut, 1/4 inch. Now, I'm going to put this on a part similar to, let's say, an unfinished end, and we're just going to deal with the left unfinished end. So here's the front of that finished end over here. And this one stretcher is going to look something like from here to here. And width of the cut is going to be equal to a percentage of the part thickness. And the part thickness is going to be a stretcher. This is what I'm doing right now, is I'm simply making a machine operation for a part stretcher, for a stretcher. And this is the front. So I'm going to have this flush to the edge, and you'll see where it goes. Now, we could play with this and bring it in some, make it a partial dado, so it's blind end, but I'm just going to make it basic. And let's say, for example, this is 4 inches. If it's 4 inches, then this number, the second point is going to be 4 inches over. So it's from the front of the cabinet, 4 inches later, we have that stretcher. That one is going to be called stretcher front. Now, let's just go ahead and keep that. And that's our, well, how about just stretcher by itself? Because since these are the same, and you probably wouldn't do it this way, but bear with me. If we go back to the CNC Smart Rules and I make a and I'm going to use the notice it's not here. I like this. This is kind of cool because I'm making a lot of the mistakes that you might make and wondering where the heck is it. Notice it's not here. That universal I just made is not here. Let's go back and look at it. And I can tell you already the reason is because I didn't name it a universal. So let's go back to the CNC machine library. Go back to that exact same machine, that part again. Remember, I named it stretcher. So that's right here. You can't see that, but it says stretcher right there. And now, notice I said this is for all cabinet types. This is an actual part. Well, or part, machining part. So I'm going to say that's a universal. And now, because it's defined as a universal, and select part is displayed. Now, if I go back to the CNC Smart Rules, it'll show up on our list. So here we have stretcher. That piece right there, or that machining operation, is going to be on unfinished ends whenever a horizontal stretcher intersects the left unfinished end. And that's all there is to it. Now, here's the tricky part, and here's where we use the construction parameter dependency. What if on some cabinets we have 2 stretchers, and other cabinets we only have 1 stretcher? So here's what we do. First of all, we have to find out what that variable is. I'm going to go to, this is a front, but now we're going to put one on the rear. So if I test just that one displayed universal on my cabinets, on that one cabinet, this base cabinet, I believe we had 2 stretches on that cabinet, and so we're going to get 2 holes. Now, excuse me, 2 pieces of machinery. But that machining is actually, there's 2 of them right on top of each other because we have 2 of those parts. So we want one in the rear as well. So I'm going to copy that, and I'm going to add a rule, and this time I'm going to reverse it along the short axis, which is the x-axis in this case. I'm going to reverse it, and now look at it again. I'm only testing this one displayed rule. Now it's down here. So we now have 2 items, 2 machining operations for stretchers. However, let's for a moment look at all of our rules for left unfinished ends right now, because I want you to see that we have both of those front and back stretchers of machining for those stretchers. Now the question is this, and we're going back to the original question itself, and that is this: what if on some cabinets you have 2 stretchers like this, but on other cabinets, for whatever reason, you only have 1 stretcher, let's say the front stretcher? Here's what we do. That's where this construction parameter dependency comes in. First of all, we have to find out what parameter we're dealing with. This is a base cabinet. So I'm going to look at the parameter list, and I'm going to divide them up by part. Here's our horizontal stretcher. And now here's the number of stretchers for base cabinets. Notice the number is 2. Also, notice the parameter number itself, the parameter ID itself is number 75. So if we come back here and we say, ignore this rule if, let's say, parameter number 75 is equal to, there's a number of options here, equal to or greater than, equal to or less than, or not equal to. I'm just going to say equal to or greater than. Well, what the heck? How about greater? Equal to. We'll do equal to. If it is equal to what number? To 2, then ignore this second, this reversal. Watch what happens now. if I look at that exact same cabinet, notice that rear machining does not occur. The first one does. Why? Because on that particular cabinet, we said, look at variable number 75. If the answer is, if the value of that is equal to 2, then ignore it. Another way of putting that, and why I want to say equal to or greater than, because what if you have 3 stretchers for some crazy reason? Or you can be dealing with another part of some sort, and now you have 3 of them. That's why I said you might want to say equal to or greater than, because if you had 3 here, it would not show up either. But for our example, we're just saying if it's equal to 2, ignore it. Now, you might ask, well, wait a minute now, those are construction parameters. And on those construction parameters, they are global for the entire room. Well, not necessarily. As you know, here we have two horizontal stretchers, but let's make another cabinet now. Let's just copy this cabinet. Well, let's just make the one beneath it. Number 2. On number 2, we have 2 horizontal stretchers, but we're going to tell a program that the parameters I'm going to deal with now are for this cabinet only. And on top of that, I'm going to tell a program that I only want 1 for this cabinet. So we now have 1 stretcher. We don't have any machining for the rear, but on the other one, we have 2. Let's go adjust our smart rule to be more appropriate for a real live type of operation. Notice down here where it says parameters, these cabinet-specific parameters say on. Generally, you want these to be off. But in this particular case, we're making something very different on that cabinet. We have 1 stretcher on the second cabinet, 2 stretchers on the top. Now let's go and adjust our smart rule so that it's doing what we really want it to do. Here, we really want to say that if variable number 75 is equal to 1, or better yet, if it's not equal to 2. See, there's a number of ways you could do this. You could say if it's not equal to 2, or if it is less than 2, or if it is equal to 1, then ignore the parameters. So there's no one particular way that's right. All 3 of those happen to be correct. It depends upon how you're building and how many times you're going to be changing number of parameters like this. So in cabinet number 1, we have 2, and if we look at, we're going to test all the rules for left unfinished ends. If we look at number 2, excuse me, cabinet number 1, where we have 2 stretchers, because of the way this is set up, we should get machining for 2 stretchers, the front and the back. Hallelujah, it worked. So we have a machine for the front stretcher, machine for the rear stretcher. Now, we're going to look at the machine for cabinet number 2. Remember, cabinet number 2 only has a front stretcher. So we only have machining for the front stretcher. Now, there's an awful lot. Now, this is just one example, but there's a lot of implications that you can deal with having to do with making these smart rules perform exactly the way you want based upon the parameters and the values of those parameters. So let me ask this. Are there any questions on this subject or this topic that we've covered so far? Well, there's no question.
Remember, you can write them down or type them into the chat if you have any questions while Frank is talking as well.
Okay. Repetitive placement. Let me ask you this, before I even go here, I want to know basically how detailed I should get here. Are any of you thinking in terms of lockdown, the use of lockdown construction? If you are, raise your hand. Don, if you see anybody raise their hand, let me know. Okay, you're not. Well, in that case, I'm just going to cover this very quickly because you might want to. It's kind of a cool system. I personally prefer blind dado construction far more, but it's still a cool system. If I go into room information, wait a minute. Here, let's do this. We have this cabinet. We're going to look at this right now. And as we've looked at this before, we're going to look at this unfinished end. I'm going to view the machining on this unfinished end with the CNC definitions that currently exist. Okay, so we have a dado cut, adjustable shelf holes, hinge plate holes, and drawer guide holes. Now, all I'm going to do, and by the way, what I'm about to do has some far-reaching effects also, because if you're dealing with somebody, with a customer, especially if he happens to be a contractor of some sort, and he knows something about building cabinets, he may not want whatever kind of construction you're using. If you are using butt joint construction, you probably say, I don't want that, thank you very much. No. But you have a CNC operation that generates butt joint type of machining. All you got to do is change it to, let's say, blind dado or lockdown or dowel construction. So in order to change an entire job from one kind of construction, one kind of machining, over to an entirely different kind of cabinet construction and machining, all we do is what I'm about to do here for lockdown. I'm going to go into our door and drawer information, maybe, right here. Construction method, I'm going to change that construction method to lockdown. When I hit OK, here's what's happened.
Frank,
The construction.
It looks like it's.
Say again?
It looks like it's frozen. I don't know. Is it just me?
Is anybody else having problems with the screen?
Yeah, people are saying me too.
Can you?
Okay, now it's good.
Okay. All right, so now I just changed the program from, or this job, from, let's say, blind dado construction, whatever I had in there, to lockdown construction. The same thing, what I'm about to show you, can be true of any particular type of CNC machining. But now, if I look at that exact same cabinet, notice the side is notched instead of separate sides or separate toe kicks. And now if I click on that unfinished end and I view the machining of it, watch the difference. That is a gigantic difference, although it may not appear to be, because these holes, you have 3 holes in here, and not only on each of these machining, you have different depths, because thus the name lockdown, because what happens here is that one part slides into another part with these plastic fasteners, and once they're in there, good luck in getting them out, because it's done. But it's a very quick way. If you ever decide to make cabinets for shipping, and you want somebody who doesn't know anything about cabinets or very little about assembling them, well, this is the way to go. It really is, because you can't make a mistake here. I mean, you'd have to be, you can't make a mistake here. And you guys are saying, maybe you can. At any rate, these are machined items that are different depths inside of that little pocket. And notice the drawer guides have pockets. They have a little hole right here. That's part of the lock dowel system. And each one of these is different now for the same cabinets that you want, the same job. You're going to have different sizes, different machining, different part sizes, but you can switch CNC operations that quickly, because not only do the smart rules leave and are replaced by something else, but also the definitions themselves. So now those lock dowels or any pockets, it doesn't have to be, these could be Rayfix connectors as well, because Rayfix connectors are of the same similar concept as lock dowel. But if you go into your setup, CNC setup, go into machining the CNC options. In those options, you will see pocket and dowel placement. These numbers down here, these are very rarely used, but they're still there in case they are used, in case they are needed. But down here, if I go into millimeters, it makes a little more sense. Now, these, I won't go into this because you're not using this anyway right now. But just know that if you're ever using pockets for any particular reason, or a series of holes that have to be drilled based upon the width of a part, this is something that you can use. And if there aren't any questions on this, I don't want to spend too much more time on that. Siblings. Now, I mentioned siblings last time, and it was brought to my attention a while ago that sometimes you have a CNC machine library, and this library can be pretty big. Right now, it has 29 definitions in it, but this can have a few hundred definitions in it. And if you're not using CNC Smart Rules, it can have a few thousand. At any rate, what happens with this is that in many cases, for this job or that job, your Smart Rules should be tweaked a little bit. But you don't want to make a whole new CNC library just because you have to tweak some CNC Smart Rules. So we came up with the concept of siblings. And those siblings are copies of your Smart Rules, and they use the same CNC machine library. So when you are at the room information setup screen, at that point, you can say, I don't have any siblings, but if I did, I can select the siblings here. I can select the sibling that is associated with that same CNC library, so that you can change drastically your Smart Rules for different jobs without affecting your library. It's a cool concept. So if you have questions about that later on, if you don't have one, or do you have any now? Let me ask you any questions on that now before we go on. If not, if you do get questions later on, just let me know.
Frank?
Yeah.
What screen are you looking at? We're looking at the home. Is it frozen, or is that?
I'm at the job and room information screen.
Yeah, it froze again then.
Are others freezing as well?
Yes.
Yeah? Well, that's not good.
Yeah.
Let me know if it changes. Okay, you should be looking at a graphic screen, are you? Okay, well, that's a bummer. Well, we have about another 10 minutes. Here, I'm going to end the recording.